So NOCl, nitrosyl chloride, decomposes into nitrogen monoxide and chlorine according to the equation above. What is the correct formulation of the equilibrium expression of the reaction? That's very easy. The products over the reactants, and every one of them is raised to the power of its coefficient. This means that answer is C. So first one to the power of 2 because 2 moles divided by second one NO to the power of 2 because 2 moles multiplied by Cl2 to the power of 1. Let's see next question. N2 plus 3H2, this is a Haber process, forms NH3, has equilibrium constant of almost 2.7 multiplied 10 to the power of negative 3. No, it is 10 to the power of 3. At certain temperature, what is the equilibrium constant? If you made the calculations, you will find that, what is the equilibrium constant? I give you a value of 1 mole of N2, so I need the value of 4 moles of NH3. I can see that two things happen in this equation. The first thing is that the equation is reversed because I have NH3 on the right side here and I have it here on the left side. So I need to make the reciprocal of this value. So I'll get 1 divided by 2.7 multiplied 10 to the power of 3, and this one has to be powered 2 also. So make this one to the power of 2, then get the reciprocal of it, which means get 1 over 2 point the Ka, which is the Ka to the power of 2, and then 1 over that. You will get the answer. You will get the correct answer. Let's try to do it on the calculator. I'll find it is C, 1.37 multiplied 10 to the power of negative 7. See the next question. What is the value of the equilibrium constant when the equilibrium concentrations are O2 0.8 and O3 0.8? So I need to find the power required. O2 is 0.8 to the power of 3, and this will be in the denominator because it's reactants, and O3 in the numerator, it will be to the power of 2, which is 0.8 to the power of 2. So 0.8 to the power of 2 divided 0.8 to the power of 3 equal to 1.25, which is answer number A. The reaction above has a value of Kb is equal to 1 multiplied 10 to the power negative 4 at 25. I'm given the equation A plus 2b, give me x plus y. General equations tells me which of the following relationship is correct about the equilibrium at 25. The partial pressure will be equal to the partial pressure of y. A is equal to y. A is greater than x. A is less than y. B is equal to y. I have here a very small value, 10 to the power of negative 4, shows that the balance is very much on the left. We said that if the value is more than 1, then it's mostly to the right. If it is less than 1, it's mostly to the left. So this means that it is mostly to the left. There are more reactants than products, so partial pressure of A must be greater than the partial pressure of X, which is the correct answer, number B. A and D, I cannot say they are correct because A is equal to Y and B is equal to Y, which means that it's never more than them. If A or B is equal to Y, it means that the reactants is never more than the products. And C is incorrect, as there are more reactants in the product. There are, in this reaction, there are more reactants in the products. Note that A will be less than the partial pressure of Y. So all of them, the correct answers, A and C and D, is telling me that there are more reactants, there are more reactants, products than reactants, not, sorry, more reactants than products, not products than reactant, as is the case. The case is -4, the case is -4, so the reaction is mainly going where? Mainly to the left. There are more reactants, but the all correct option, incorrect options A and C and D is telling me that it is going forward, it's going to the product side. So that's why they are incorrect, and the only one correct is the B. The next question, let's see. The reaction between hydrogen and hydrogen produces ammonia gas. If the equilibrium constant for the reaction is X, what is the equilibrium constant for the following reaction? N2 plus CH2 give me 4NH3. Oh, I have doubled here the equation. All I have done is that I have doubled the equation. I did not reverse it or anything. It is the same. So I just doubled it. When I double it, I make the K power 2. So instead of having the value of K, it will be k to the power of 2, which means that it is, instead of it is x, it will be x to the power of 2, which is answer number C. Next question here. Reaction between below has an equilibrium constant k equal to 1.1 based on the value of the following must be true. You are saying that the value is 1.1, which is mean that it is bigger. We said that if it is 1.1 bigger than 1, means that the products are more than the reactants. So y is more than x. That's why the answer is D. All the other options showing that it is either x is equal to y or x is more than y, which is incorrect. Otherwise, the number will be 10 to the power of some minus something. It will be less than 1. Next question. Okay, consider the following reaction at different temperatures. The equilibrium constant were measured at each temperature, T1, T2, T3, T4. And let's see which of the following correctly ranks the amount of products in the equilibrium mixtures from least to most. Yeah, that's very easy one. The answer is D. 1 is the greatest because it has the 1 multiplied 10 to the power of negative 2. The larger the Kc value, the greater the amount of products compared to the reactants. For more Kc, I have more products than the reactants. So if I arrange the Kc in following order from the smallest to largest, so I have T1, that's 0.01 is the smallest one, and then I have the one after it is T3, which is equal to 1, and then I have T2, which is 1 multiplied 10 to the power of 1, which is equal to 10, and then T4, which is 1 multiplied 10 to the 1 multiplied 10 to the power of 2, which is 100. So the arrangement is telling me T1, T3, T2, T4, T1, T3, T2, T4, which is answer number D. The next question, the one before last, is that I'm saying consider the following two equilibrium reactions. Which of the following is correct in mathematical relationship between Kc1 and Kc2? I see that it is reversed and divided by 2. Since it is reversed and divided by 2, it is equal to 1 over the radical of over Kc1. 1 over the radical of Kc1. Why it is reciprocal? Reciprocal because it is reversed. And why it is to the radical? Because it's powered to half. It's powered to half because half mole. Power to half means radical the value. Last question, consider the following equilibrium reaction. Initially, the following concentrations were present. At equilibrium, the concentration of H2 is found to be 0.02. What is the value of the equilibrium constant for this reaction? Looks like a difficult question, but let's simplify it. So let's try to do it slowly for this one and find the answer. I'll make the ice table. So let's make the ice table and see the question and its answers. So as per the ice table, when I start with 0. I start with 0.2. This is our slope, the symbol for the equilibrium here. So I have the ice table telling me I start with 0.2 and 0.08, and then I didn't have any products at the beginning. Then I decrease 0.06. How did you know that you are decreasing 0.06? Because you said that this is the initial concentrations at equilibrium concentration of H2 is found to be 0.02. Since you found that this value is 0.02 and initially it was 0.08, this means that you have decreased 0.06. Since the ratio is 2 to 2, so here you will decrease also 0.06. And since the ratio here is 2 also, so you increase 0.06, and here mole is 1, so 0.03 only divided by 2. Since I found one of them, I can find all the answers 0.02, 0.014, 0.03, and 0.6 by adding the starting concentration to the change in all of them. Then I would divide the products, which is N2 concentrations at 0.03, multiplied by the other product, which is 0.16, but this time to the power of 2, because it is coefficient 2, and divide the multiplication of these two by the multiplication of these two. Here 0.14 will be to the power of 2 as it is moles 2, and here is power 2, which is also 2. So I will get 0.14 to the power of 2, 0.14 to the power of 2 divided by 0.02, and that one is the denominator, while the numerator is the reactance here to the power of 1 and here to the power of 2. I will get the result, which is 98.0, which is answer number B.